let us study about class templates. We have seen that in function templates you can create generic functions which will work for any given data type. Same way you can create generic classes. You can create generic classes which can operate with any data type. Okay, right? These are particularly useful when you want to play with a single class of data like stack, queue, array, linked list. Those kind of problems we can use these generic classes much. So, the most important application of this class template is with data structures only. Okay. So, till now in data structures course, when you have solved problems on stacks and queues or linked list, you have either used to implement stack, you have either used a array or a linked list, right. But here you can directly use a stack class template. We will see the implementation of that also, right. So, point is very clear, like functions you are creating generic functions to work with any given data type. Same way you can create generic classes that can work with any data type. Okay. The syntax is same as your function template, template keyword, the type name T, then the class keyword, class name, class keyword, class name, meaning this class you are trying to make it generic. Open bracket public T data means the data type of this class name will be T. Okay. Then this is your initializer list kind of a constructor, then you can write some functions like this and play with that. Okay, right. So, whatever data types you will be declaring inside classes, there you will be using T, the template name you will be using always, right. So, if I am creating a class like this, before that I will write template, I can even use this class T, okay, and I am writing the a class parent, I am writing a class parent in this public. Okay, you want to create two different variables, you can give Tx, Ty. You want to define a constructor, how to define constructor? Using a class name, using class name you will define it like this, parent of Tx or some Ta, you want to have a parameter as a constructor Tb, like this you can write this x equal to A, y equal to B, like this. This can be your class. Okay. So, this class parent, if you are passing to integer values this will work, if you are passing to float values this will work, if you are passing to one float one integer it will work, depending on this number of classes you are creating or number of type names you are creating, right. So, this is the main goal of this templates here, right. So, what I am trying to do here, template, the type name T, then the class, the keyword class and class name. Inside that, under public or private, wherever you want to give, you do not define the data type, just give T and the variable name, then the function get data and the variable name, that is the T, the type name, which type you want to play with. So, this is a generic class, this will work with any kind of data type, meaning when you create a class, maybe you can take example of inheritance. Okay, you can take example of inheritance. In inheritance, if I have a generic class here, if I have a generic class, okay, this generic class is I have this like this, I have defined a generic class. Now, you want to derive this, let that class name be some parent. Okay, let this class name be parent. Okay. Now, when you want to derive class, how will you write? You will write class child1, you will write class child1 colon class parent, you give like this. Okay. So, this parent is a generic class. So, this child1 can play with all integer data, child2 can play with all floating point data, like that you can even do inheritance also. We will see, let us understand this with some good examples. Okay. Let us see this simple program here, right. So, there is a template type name T, class box, private variable is there T value. So, value is a variable name, I have given the type as T, then this is the initializer list, same as your constructor to assign value. Okay. Then I have a function, see we generally write void function name. Here I am writing t function name, return the value, then void set value tv, value equal to v. So, set function and get function I have written here. Everywhere in this function I have used t, wherever there is a variable name I have used t. Okay. So, I have created a template for class and everywhere I have used t like this. Okay. Now, from main when I am creating object for this class, when we are creating object for this class, you see box, the type of value which I am sending, int box 42. Okay. Int box 42, meaning I am for this box class, I am creating an object int box. Okay, I am creating an object, it is like box int object 1 with 42. So, when I create an object for box class, when I create an object obj, this default parameters constructor is executed. What value I am sending? 42. So, this value contains 42. Same way I am creating another object for class box of type double, this time double obj 2 with 3.14. Same way double string with hello. These three are the objects of this class box. Okay. When I get those get value when I do, you get those three values again here. So, this is a generic class. This is a generic class which is taking the values of any type. You are creating object for this class using integer, this works for integer. You are giving for float, this works for float. For a string, this works for string, right? And you are trying to print those values here. That is about the class templates. Okay, very simple and clear. You are creating a generic class where this class can work for any given data type. Okay, so simply create a template, put t wherever possible. Wherever there is no data types, you put t there. When you put t like that, wherever there is a scope, then immediately this can work for any given type, for int, for double, for string, anything it will work. And I am trying to invoke that function using that particular object. This inbox, double box are the objects. Using these objects, we are trying to invoke these particular functions inside that, right. So, this is a simple example to understand how class works with templates. Okay. Generic classes we are trying to create, right. Let us see this. So, how can we implement stacks using class templates, okay, right. How we can implement the same for stacks. Let us see. So, template type name t, class name is stack. Okay. So, this is general operation. You know, if you want to push elements into the stack, you have to simply make plus top of value. If you want to pop some element, you have to return the top minus, right. I implemented this for generic thing. I implemented this like we do in stacks implementation using arrays. Okay, nothing extra. But when I am calling from main, if I am pushing, when I am creating an int stack, meaning I am creating an object with integer values, I can push 1, 2 and I can pop the element and see. When you create an object for this class stack with the string as the data type, then you can push hello world and you can pop it. Okay. So, here the point here is always when you write a program for stacks using integers, it will work only for integer values. It will push in integer because you are creating an int array there. You are creating an int array there, int ARR of 100, like this you will be playing with, right. But here you gave t, here we have given t as the value. See, always t in the function, t as the input, right. So, when you create a generic template, generic class for stacks using t, this stack body or this stack class can be used for integer numbers, for double numbers or for strings. Okay. This is the advantage. So, here if someone asks you to write a stacks program with which can handle any type, you have to go for this class template logic. Okay. Now, this stack can take any values, either integers, either strings or double or any other data type which it wants, right. So, this is the advantage of using class templates. I hope with this example you understood how a generic class template is created for stacks. If you want to give more than one argument in a class template, how we do that, right? If we want to give more than one argument, let us see how do we give more than one argument. So, template class T class U, this is common. Okay. Instead of type name I am using class here. So, template class T class U. So, there are two different types. In this example we are having only one type. So, one type of value and everything is same, one type, and I am able to play with single value here, int, float, string, single values as input. But if I want to play with the multiple inputs, to this class object, so template class T class U and the class name is class A. So, this class is the actual class, that object oriented programming class, class A. In this I am having T, X, U, Y, means private variables, one of type T, another of type U. Then public, a constructor here is there. Okay, a default constructor is there here without any arguments, default constructor called, right. So, in main you see for class A, name of the class is A. In this I am giving the data types char, char. I am creating an object. Small a for this class capital A. Okay. What of the type I am giving here? I am giving char and char. We are giving here char. When we give char and char here, immediately when once an object is created, the default constructor will be executed. So, it will say constructor called. Again, you are for this class you are sending int and double as the values. And you are creating an object B, right. So, when you create an object B like this, immediately this constructor will be executed. Anyhow, we have not written any functionality here playing with those values, but this is just to demonstrate that you can have multiple values. Or if I would have implemented the parameterized constructor T x or maybe T A and T B, T A and U B, okay, a parameterized constructor inside this class A. You can have it like this. You could have written x equal to A, y equal to B. Accordingly, you can done. These assignments can be done there. So, you have to write here A of 10 comma, since another one is a character, you can give 10 comma small a. Here B of 10 comma 5.25. Like this you can create objects and pass the arguments, right. So, like functions, classes also can have multiple arguments. You have to specify them very clearly when you are defining the template, and in the whole class definition you have to use those template names T, U, whatever you are defining, T1, T2, whatever names we are giving, we can define them in the class. So, this is about the class templates and how to give multiple arguments for class. Default value, can we give a default value for a template argument, right. So, in this example we are giving two types here. We want to have more than one type of argument like this. I want to pass A with 10 and single quote A. Also, I want to create another object 10 with 20.5, right. So, you are having two arguments here. So, you have to create two class types for templates. Okay. You have to have two arguments. Here I have two arguments T and U. One argument I want to hard code it. Like default arguments. We have already in the beginning of this course of C++, we have studied default arguments concept, meaning, right. So, one of the classes you can pass here, the other one by default can be this. Okay. So, what happened in this example, class T, class U, I am writing equal to char like this. Then class A, the values constructor, when you are creating an object, you can just pass only the first type. You can give only the first type and create an object. Okay. You can override it. If you do not want character, this is a default value, this is a default value. So, when you give, you need to give only one, you need not give the other one. If you want to override it, you can give like this also, int comma int of b, then this will become int, not character. Okay, this will become int, not the character. So, this is about default value for template argument. Okay, like this we try to create one argument as the default value. Class, the next one, class templates with inheritance. Okay, I hope this you understood. Instead of giving two classes like this, you can hard code one as a default. Then the next one, class templates with inheritance. Again, inheritance, I will have a parent class, generally class parent, and then we will have class child, which is derived from class parent. Okay. So, this child class can inherit all the properties, meaning all the functions or the members of this class parent in its child class. Okay. Now, I am having a generic class. I am having a generic class. Let us go to this example. See here, this already we have seen, class box, private t value, then I have get value, set value. I am using for 3 different data types here. So, this is a generic class. Now, I want to create a child class for this. I want to implement the concept of inheritance here. Okay. So, I want to create a child class, right. So, what is this child class? For this class box, I am creating another class, class shape, which is derived from class box. Okay. We are trying to create a child class for class box. Now what about this template? What about this template logic? How will it work here? How to use this generic classes in inheritance, that we have to see, right. So, class templates can also combined with inheritance to create generic base classes that are extended by other classes. So, you are trying to create generic base classes. This is particularly useful when you want to define a base class template with general functionality that specific derived class can build upon. Okay. So, general thing you want to put in base class, remaining thing the derived classes can take care of that, right. So, let us see this example program to understand how class templates with inheritance. Slowly see this simple example, but little lengthy. See, I am having a template class type T, class shape. There is a class 1, okay, there is a class shape which is written using template. So, there is a protected variable T area, public, I have a constructor, then this is a pure virtual function, then I have a function T get area. Okay. So, this is a generic class, this is a generic class shape. Then I have, see, I am trying to derive this generic class shape, okay, into another class rectangle, So, you have to write again template type name T, class rectangle, derived from public shape, type T. This T we are passing as an argument here, right. We are showing it that the type of this shape is T, then T length, T width. Okay. So, this again a default parameter as the constructor, and I am calculating something length here. Okay. Then I have another child class, class circle, public shape. See, this shape is rectangle, this shape is circle. Okay. Again T radius, constructor calculation. Now, see the main, we will again come back to these functions, rectangle class, this class, double rect, I am giving 2 values here. Okay. I am passing 2 arguments because I am having a parameter as the constructor. Then I am with this object rect dot computer area, this will execute, compute area, this will execute. Then circle 7.0, for this circle I am giving one value 7.0. So, this where is the constructor here for a single value? It is here. Okay. So, circle 7.0, this is the constructor what we have here, compute area, it is computing it and I am getting the area. The point here is to show that you are having one generic class. Okay. Generic class has a function compute area, it is having a function compute area, which I am using in this class, I am using in this class. Okay. Why did I define this as pure virtual function? If you write function equal to 0, this is called pure virtual function. When you write like this, pure virtual function, right. So, here when I am for this child class rectangle, I am creating an object. Okay. This child class, for this child class circle, I am creating an object and I am invoking these functions there, right. So, here it is simply mean that if you are implementing inheritance, okay, if you are implementing inheritance using template, then this should be added to every child class like this. Okay. So, this can work for any given type, this can work for any given type, right. So, this is about class template with inheritance. Okay. If you summarize what we have seen in class templates, right, like functions, you can even generalize classes, we can even generalize classes, you can create generic classes like this. This is a generic class which can take any value, it can take integer, float, string, anything. Okay. And we can even pass more than one argument like this. Also, you can even give one default value for a one of the arguments, and you can even implement the class templates with inheritance. Okay. Same type T will be continued everywhere, and this is the main function which we are calling. So, this is about class templates in C++. So, templates of two type, function and class templates.